Hey guys, this is Math 152, assignment A, question 5. So question 5 asks you to find the inverse of some matrix, and it has values, and it has like P and just has letters in it instead of numbers. Well, it has numbers as well, but it's not like it's just all P's. There you go, and we're asked to find the inverse of this. No, we're asked to find values of P for which the matrix is not invertible. So obviously, the determinant has to be 0 here for our answer. And the determinant here is 0 when we put this into either lower or upper triangle form, and we take the sum or the product of the diagonal. So I'm going to start row reducing this in order to put this into reduced form. So we end up with, not going to do anything to this row here. I'm just going to switch the bottom two rows. And then I'm just going to switch some rows around again. Get 1, 0, squared up here. I get 1, I get 1 over here, and 0, 1. There. So that's after we switch around a little bit. So continuing on, we're going to leave the top row as it is. We're going to subtract the top row from the middle row. If you can notice up here, if we do that subtraction, we get 0 here, -1 here, and P minus P squared. Now to the bottom, we're gonna, since we have all our diagonals except for that 1 there, except for this 1 right here, everything now is in lower triangle form. So we're gonna find a way to take that 1, which is just gonna be adding this row to that row. So that yields a 0 here. Get this row plus that row, so -1 plus 1 is 0. And we get P plus P minus P squared, which is 2P minus P squared. If you have trouble following that step, since I'm trying to do this relatively fast, because I don't want this video to drag on longer than it has to. So if you have trouble following this, then try doing individual steps on your own. And if enough people have problems, then I'll just do it all over again and take my time. So obviously for this, we want the determinant, which is the product of the diagonals, to be 0. Obviously the 1's don't matter, all we care about is 2P minus P squared. Factor out a P, and we end up getting that P equals 0 and 2. And this is values for which the matrix is not invertible. So don't get confused with that. Next, B. Now B asks us to do the same for the transpose. So first, let's write down the transpose. There it is. And that's the same thing, we want to row reduce it. So let's just get to it. I'm going to switch rows around. The P's on the top, -1 stay where they are. There you go. Now, I'm going to add the bottom row to the top row. So 1 plus -1 is 0. 1, 1. There we go. And now we are going to divide the top row by p and subtract it from the bottom row. P squared, 0, 1, 1. So if we divide the top row by p, we get 1, 1, and p. And if we subtract that from the bottom row, 0, -1, 1 minus p. Now, all we're going to do is take the middle row, and we're going to add it to the bottom row. 0, 1, 1. So 0 plus 0 is 0, 1 plus -1 is 0. 1 plus 1 minus p gives us 2 minus p. So now the product of the diagonals is just p times 2 minus p, which we want to be 0. So p is 0 and 2. There we go. Now there's also a wrong way to do this. If you didn't do it somewhat like this, and if you instead took the row with the p's in it and divided it by p, you're going to have lost the result that is 0. Whenever you're solving anything, quadratics or matrices or anything, you never just divide by one of your variables because you're going to end up losing a solution. So I'm just going to quickly on the bottom here, this is the right way to do it. I'm going to quickly go through the wrong way to do it. The wrong way to do it is as follows. There's our matrix. The wrong way to do it is to start by dividing the bottom row by p. Right. It's not like wrong where you just end up losing solutions, because if you look at how it goes through, I'm just going to take the top row and I'm going to add it to the middle row. Getting 0 here, 1, 1, 1, 1 p. Now I'm going to take the top row. Sorry, I'm going to take the middle row and I'm going to subtract it from the bottom row. So this is 1, this is 0, this is p minus 1. And now I'm going to take the middle row and subtract it from the bottom row. You end up getting 1. What am I going to do? No, sorry, I'm going to take the top row and subtract it from the middle row. So this is 0. The top row, subtract it from the bottom row. I can't speak right now. 0, p minus 2. There. Now, the product of the diagonal is just 1 times 1 times p minus 2. If you want this to be 0, we get p equals 2. Notice you only get one solution here, where in the correct way to do it, you got two solutions for 0, and you got 0 and 2. When you divided the bottom row by p, you end up getting just 2. This is an example of how you lose solutions when you just divide through by some number and you don't. If you just divide through by a variable, you end up losing solutions. So now we're going to do part C. Now part C is a very, you just explain it really. The part C is final solutions of the homogeneous system bt of b x equals 0. It wants you to find all the solutions. When p equals 1. So this is when p equals 1. Well, when p equals 1, this is invertible. This is also invertible. So you can take the inverse of that product. Now, by definition, now this is just a straight explanation. There is no way of actually mathematically showing this, because inverse times 0, we just get x to be all zeros, which actually is an explanation. Really, this is some matrix. It doesn't matter what matrix it is. Huh, I never really actually realized this before. But if you go x equals B transpose B inverse times 0, doesn't matter what B transpose times in B is in what the inverse of that is. X is always 0. Your solution is just a matrices of all zeros. That was way easier than what I was about to say. Just stick with that. So there we go, and that's how to do 5. And 6 is coming soon.